right, so we are working on our Major Quiz 1 review, and we're going to find the union and intersection of some sets to start with. So we're going to do example 1 here we have set A and set B. So the first thing we're going to do is find the union, which means it includes all of set A and all of set B. Now you can put it in numerical order if you want to, but if you would like, you can just start with set A. So if we have set A, we're doing A union B. So we're going to put set A in there. Remember, the union looks like a U. It's the union, and think about it as like a bowl or something that you can put everything into. So the union will hold everything. The intersection will only hold a little bit where they are overlapping. So I'm going to write all of set A, and then I'm going to go look at set B. So that's all the numbers in set A. And in set B, I already have the 1, I already have the 2, so I need to do the 4. I don't have the 5. And then I don't have the 8, but I already have the 9. So you don't have to put them in numerical order. So that's the union. That's everybody put together. Now we're going to find the intersection. So think about this like an N. It's not an N and this is not a U, but think about that as a union and this is an intersection. On top of the intersection, you can only put a few things and then it would topple over. Well, there's only a few things it has in common. So we're looking to see, well, they both have a 1, they both have a 2, and they both have a 9. So our intersection will be 1, 2, and 9. And now we're going to draw our Venn diagram. So you want to make sure you label set A and set B. You can put them inside or you can have them on the outside. It doesn't really matter. So I'm going to put my 1, my 2, and my 9 here. Now I have to look at what was also in set A that I don't already have. So I have the 1, I have the 2, I don't have the 3, I don't have the 6, and I don't have the 7, but I have the 9. In set B, I have the 1, I have the 2, I don't have the 4, I don't have the 5, I don't have the 8, but I already have the 9. So that is a complete Venn diagram for those two sets. We're not worried about the universal set in these examples. We're just doing what we have here. All right, so let's go to our next Venn diagram. We're going to do one that has a triple set in it. It's going to have 3. So we're going to look at finding the intersection between all of them. We're not going to find all of the unions because that really won't help us draw our Venn diagram. I'm trying to write and speak at the same time, and sometimes it can make it difficult. Okay, so we have set A, set B, and set C. What we need to do is find the intersections between each of the sets, and then for all of the sets, and then we'll be able to draw our Venn diagram. So between A and B, they both have a 3, and they both have a 5, and they both have a 7. So for that one, we have is equal to 3, 5, and 7. Now, when we look at this A and C, we can see that we have 3, we have 4, we have 6, and we have 7. So we have 3, 4, 6, and 7. And make sure when you're doing these, you don't use parentheses. You actually use the curly brackets. Between B and C, they have 3, and they have 7, and they have 9. So 3, 7, and 9. And then between A, B, and C, we can look at what they have in common here. So they all have a 3, and they all have a 7. So those are the only two things that they have in common through all three sets. And you can look at it this way because it had to have in common with the two sets in order to have it in common with all three. So instead of staring at them all, but you can always double check by looking. All right, so we're going to have A, B, and C circle. This time I'll put them on the inside because it doesn't really matter which way you go. The intersection between all three is going to be a 3 and a 7. Between A and B, we have the 3 and the 7. We also need to have the 5. So this is what they both have in common right there. Between A and C, we have the 3 and the 7, but we need to put a 4 and a 6. And between B and C, we need to put a 9 because we already have the 3 and 7. Now we need to look at our sets to see what else we need to put in there. So for set A, we have the 3, the 4, the 5, the 6, the 7. We don't have the 8. So I'm going to put an 8 in that set. For B, we don't have the 1, but we have the 3, the 5, the 7, and the 9. And for set C, we don't have the 2, but we have the 3, the 4, the 6, the 7, and the 9. So that would complete our Venn diagram on there. Everybody is accounted for. All right, so the next type of problems we're going to look at are tree diagrams. So there's different kinds of tree diagrams to do. We're going to look at one that is some food. It's pizza sale. We'll look at a parent-child and a supervisory type of relationship. So the first one we're looking at is Bob's Pizza. So for Bob, he's having a sale at Bob's Pizza Place, and you get 1 meat topping and 1 extra. So the crust choices are thin, regular, or pan. That means that's the first thing we're going to take off of our tree diagram, and then we'll put the meat choices and then the extras. So the first thing we're doing is we're setting up Bob's. He's having a pizza sale, and he's got 3 crusts. So we're going to put off our 3 crusts. We've got thin, regular, and pan crust. The choices for the meat are ham, pepperoni, and sausage. So that means for each one, we're going to have 3 that come off of here that are going to be ham, pepperoni, and sausage. And we have ham, pepperoni, and sausage. And ham, pepperoni, and sausage. Now you don't want to use abbreviated letters because sometimes those will repeat, and you want to be able to look at your tree diagram and see what you're doing. And if you only have letters, you really don't know what that means. All right, so we've got our meat. Now we're going to do our extra topping. So those choices are mushroom, pineapple, or olives. So that means for each one, we will get 3 that come off of that. So I'm going to draw my 3 parts, and then I'm going to come back and do all the writing. There is a lot of writing on this one, but you get to understand how this works. If you notice, they're all connected. I don't have any gaps where the words are. I have all of them connected at those dots right there, so we know what we're following here. All right, so we have mushrooms, pineapple, or olives. So now I'm going to go back and write mushrooms, pineapple, and olives. Mushrooms, pineapple, and olives. And mushroom, and the order does not matter. Pineapple, and olives. And then we'll come over here, we'll write mushrooms, pineapple, and olives. And mushroom, pineapple, and olives. And again, pineapple and olives, and mushrooms, pineapple, and olives, and mushroom, pineapple, and olives, and one more set. Mushroom, pineapple, and olives. So what that allows is if I want to go make an order at Bob's Pizza, and let's say I want thin crust, I can say, you know what, I want thin crust with ham and pineapple. Or maybe I want regular crust and I want sausage with olives. Or maybe I want pan pizza with pepperoni and mushrooms. So you get to follow the flow chart. You can pick any combination on there. Now there's another type of tree diagram that is a parent-child relationship. So on this one, it's going to show kind of like a family tree. So if you think about that, it's going to have the people, and it's going to show how the family is connected together. So this will be number 5. So Billy Bob has 3 children. He has Bobby Sue, Billy Jack, and Jim Bob. Bobby Sue has 3 children, Mary Ellen, Susan Marie, and Marietta. And Billy Jack has 3 children, Jackson, Johnny, and Billy Ray. Jim Bob has 2 children, Jimmy, Joe, and Walton. And we need to draw their family tree. So the first thing we're going to do is put Billy Bob, because Billy Bob is the parent. And he has 3 children. And those 3 children are Bobby Sue and Billy Jack and Jim Bob. Bobby Sue has 3 children, so she's going to get 3 branches off of hers. And they are Mary Ellen, Susan Marie, and Marietta. Billy Jack has 3 children. He has Jackson, Johnny, and Billy Ray. So Jackson, Johnny, and Billy Ray. And then Jim Bob has 2 children. He has Jimmy Joe and Walton. So we can look at this and see who the family is. We can see that Billy Bob has 3 children, Bobby Sue has 3 children, Billy Jack has 3 children, and Jim Bob has 2, and we can see their names. The next tree diagram you could do is a supervisory one where you have a boss. And in this case, we have President Long. I don't have to write president, I can just write Long. And he has 3 department heads. So this is kind of like what you might see at college with department heads, or it could be in a business, any kind of thing. And those department heads are Thomas, Matthews, and Marks. And Thomas has 2 different assistant department chairs. So he has 2 assistants, and those are Davis and Stewart. And then Matthews supervises 3 assistant department chairs. So he has 3 coming off of his, and those 3 department chairs are Sam's, Reynolds, and Allison. And then Mark's has 4 departments, or assistants, 4 assistant departments chairs. And those are Clayton, Mays, Hillen, and Darby. So if you were trying to figure out who's under who, you can look at that tree and see who is doing what. All right, so that's the tree diagrams. We're now going to look at graphing and tables. So we're going to look at our graph here and we're going to write some information. So looking at the graph, we're going to write the data in ordered pairs. So this will be number 7. So looking at the data, we're going to look at this part here first. We're still looking at like x, y. So here's this, the x's, and then we've got the y's going up. So we're going to start with the year 2003, and with 2003, when we go up, we're going to hit the inflation rate of 2%. So this is doing the inflation rate for the United States from 2003 to 2013. When we look at the next one, we are looking at 2004, and we're looking for the value. We are past 3, but we are not all the way to 4, and we're not even quite halfway to 3. So here you're going to do a little estimation. So it's not quite halfway, so I'm going to do like 3.3. You just want to make sure that the number you choose makes sense. When we get to 2005, if I get to 2005, I have to be above 3.3, but I don't know that I'm still quite halfway there. So that means I need to go like 3.4. And as long as what you choose makes sense, it'll be fine. In 2006, we go and look, and we're right at about halfway. Here's the mark here and the mark here, so we're going to go with 2.5. For 2007, we look, and we're really right at 4. For 2008, we're right down here at the bottom, but we're maybe slightly not at 0, so let's go with like 0.1. I don't know that the inflation rate's ever at 0. In 2009, when we go up, looks like we're a little past halfway there, but we're not quite all the way. So let's go with like 2.8. Nope, that would be 3.8, right? Nope, 2.8. Sorry, I looked wrong when I went back. So 2.8. All right, then 2010. In 2010, we're a little past 1, and there's 2. We look like we're right about in the middle again, so let's go with 1.5. In 2011, we look at our graph and we go up, and we're like right on 3. In 2012, as we come up, we're past halfway. We are more than we were at 2010. So we have to make sure we go up a little bit, but we're not quite all the way up to 2. So let's go with like 1.8. And then in 2013, we're a little past 1, but not too far. So let's go with like 1.2. So as long as your numbers make sense, it'll be okay. So the next questions we have, we're using the graph to figure it out. Write the data in ordered pairs. We did that. So now what was the inflation rate in 2011? Well, that's the same value that we found in our ordered pairs, but we can look at it again if we need to and find that for part B, the answer will be 3. And then for part C, what year had the highest inflation rate? Well, that's the one that had the highest peak in the graph, and that's going to be 2007. So that's all you need to do for part 8. So let's go on, or for part 7. Let's go on to question 8. And in question 8, we're going to do some graphing. So we're going to graph the following ordered pairs. So we're going to just graph like we would have, because they're just points. So we're looking at making a graph here. Now, our highest number is 7, so I'm going to make 7 hash marks on each part. 1, 2, 3, 4, 5, 6, 7. All right, so even though we're not doing algebra, we're still doing a graph like it's an x and a y because that's our x, that's our y. So our x is positive 3 and our y is positive 5. 1, 2, 3, 4, 5. So we're going to plot a point at 3, 5. And then we're going to plot a point at 2, 7. And now we're drawing a line between these, so we're just going to draw the line and graph it. That's all that you're doing. So that's the first graph. The second graph, we have 5, -2, and -3, 4. So we need to go clear to a 5. I'm just going to make the graphs kind of even and do 5 on each. So 1, 2, 3, 4, 5. Our first point is positive 5, -2, and then we have -3 and positive 4. And we plot the point and draw the line. So that's all you're doing on this. Make sure you put the arrows, that's your end of your line because it is a line, and go past the dots. All right, so our next problem, number 9, we are looking at a graph and we need to plot the points that are there. We need to write the ordered pairs of the plotted points. So we've got R, S, T, and U are the points that we have. So for R, our x value is at -5 and our y value is at 3. So -5, 3. S is at -1 for x and for y, so it will be -1, -1. For t, our x value is 0 and our y value is 2.5. So we'll write 0, 2.5. And for u, it is 4 for the x and 1 for the y. So 4, 1. That's all you need to do for that is to plot or to write the ordered pair of points. The next thing we're going to look at is the table here for the 35 students distributed grades here. And these were for the semester. And we need to figure out how many total students pass the class with an A or a B. So this is number 10, part A. So for an A or a B, they got 5 A's and 11 B's. We're going to do 5 plus 11, which will get us 16. For part B, how many students passed the class with an A, B, or C? Well, for an A, we had 5, we had 11 B's, and we had 9 C's. So that's going to get us 25 in total. For part C, how many students failed the class with a D or an F? So we have 7 plus 3 will get us 10. And part D, how many students had a C? Well, that's going to be 9. There's nothing to add, it's just the 9 that's there. All right, so our last question is another table. So this shows the Target stores in 10 states. Which Target store has the most targets, or which state has the most Target stores? We just need to look for the biggest number, and that's California with 257. Which of the states listed in the table have the fewest Target stores? We're going to look through there and find that Virginia had the fewest with 57. What's the total number of Target stores located in the 3 states with the most Target stores? So the most, we have California with 257, plus the next one would be Texas with 149, plus the next one would be Florida with 123. And when we add those together, we'll get 529 stores. All right, how many Target stores are located in the 10 states listed in the table? Well, for this, we're going to have to add all of the numbers. So we'll have 257 plus 123 plus 89 plus 59 plus 75 plus 67 plus 64 plus 63 plus 149 plus 57. And that will get us a total of 1,003. And then the last question asks which of the two states has more Target stores combined, New York and Pennsylvania, or Michigan and Ohio. So New York has 67 stores and Pennsylvania has 63. When I add those together, I get 130. Michigan has 59 stores and Ohio has 64 stores. And when we add that together, we get 123. This is more, so the neighboring states would be New York and Pennsylvania.